Good morning, students. Today we'll start discussing about the second unit, and in the second unit we'll discuss about the classification and the regression technique. So first of all, we'll discuss the techniques which are related to the regression, and then we'll discuss about the techniques which are related to the classification. So before starting into deep, we first discuss what is the basic difference between regression techniques and the classification techniques. So when we are trying to give a label to the class, or when we are trying to predict a discrete label for a classes, then we'll call it as a classification problem. Suppose you want to predict that a person is having cancer or not, a male is a spam male or not, a given fruit is a banana or a cat. So uh, we are trying to give a label to a class. We are just trying to categorize the data into different classes. So such type of problems are called classification related problem. And the other types of problem which we are calling it as regression. In the regression, what we are doing, we are trying to predict the quantity. Suppose I'm saying that what is the size of a house. If this is the size of the house, what will be the price of the house? What is the value of the stock market today, and how it will affect tomorrow? So wherever I'm trying to predict the quantity of something, regression will come into picture. So this is the basic difference between classification and the regression. So whenever we are talking about any machine learning algorithm, supervised machine learning algorithm, we are dividing into two categories. One is called regression techniques, other one is called classification techniques. And we are focusing on regression. So in the case of regression, we'll be having simple linear regression, multiple linear regression, and polynomial linear regression. So we'll discuss first what is simple linear regression. Before discussing simple linear regression, just I'll give a quick glance that what are the different applications where linear regression works. Suppose I want to check the economic growth of a country or a state in every quarter. So here regression will perform better. With the help of regression, we can easily find these results. Okay. Suppose in the same way, I want to check the number of runs a player would score in the coming match. Suppose now IPL is going on. I want to check that as per the previous performance, what Virat Kohli can score in next IPL match. So I can use here linear regression again. So these are the some applications where linear regression performs better. Now we'll discuss in detail that how linear regression works actually. So when we are talking about linear regression, it is a statistic model which is used to predict the relationship between independent and dependent variable. Okay. So when we are talking about independent and dependent variable, we'll discuss what exactly the independent and dependent variable. So before that, I want to discuss there are two factors which will always affect the linear regression. The first factor is which variable in particular are significant predictors of the outcome variable. Means which variable we will use here which will affect the outcome of the variables. Which should be my independent variable, what should be my dependent variable, you have to identify. Second thing in linear regression is how significant is the regression line to make prediction with highest possible accuracy. We'll draw a linear regression line and how fit we are trying to draw that line so that the accuracy will be highest. So these two things we are trying to achieve throughout the linear regression, and in detail we'll discuss in further slides about these. Okay. So when we are talking about linear regression, we'll be having a equation. We have to discuss two things first. What is independent variable and what is dependent variable? So what exactly the independent variable? See, suppose I want to calculate a rainfall. Okay. I want to calculate the rainfall, and using that rainfall, I want to calculate that every year how much crop yield I can have. So rainfall is not in my control. I cannot control rainfall. It is an independent variable. But as per rainfall, you can say that this much crop we can predict in that particular year or in that particular season. So your rainfall will affect the yield of the crop. So crop yielding is a dependent variable and rainfall is a independent variable here. So we have to very clear what is independent variable and what is independent variable. And whenever we are talking about linear regression, what we are having, we'll be having one independent variable and one dependent variable, and which is denoted by equation y equal to mx plus c. So here y is a dependent variable, x is independent variable, m is called slope, and c is called coefficient. And to calculate m, we are using y2 minus y1. difference between y2 minus y1 and the difference between x2 to x1. So in that way, we can find the value of m, which is a slope here. Okay. Now I want to calculate the coefficient with least square method. Okay, so how we can calculate that? Suppose we are taking a very small data set here, which is having 5 rows, and x is representing an independent variable, and y is representing dependent variable. Okay, so the value of y depends on x. Now the same value I'm plotting in this graph. The x and y value we have plotted in the graph here. Fine. So after plotting this, now I want to find the mean here. So whenever I want to find a line, then first of all we have to find the mean. So I will find the mean of x and find the mean of y. Mean we know how to find mean. Addition of all numbers divided by total number of numbers. So x will be 3 and y will be 4. So my x and y is here 3 and 4. So this is called mean. And using this mean, I draw a straight line here. So this is the line which is crossing the mean. So after this, the same way, we have identified mean, right? After that, we are trying to draw the equation of the linear regression, right? So what we are doing, we are having x value, we are having y value, and I'm trying to find using the x value, I'm trying to predict the value of y. So for different x, what can be the value of y here? So your x is given, y is given. You will find the summation of x, you will find the summation of y, summation of x square, summation of y square, and some x multiplied by y you will find here. Fine. Now we have to keep all these things in the equation, which is y equal to mx plus c. For that, I need m value and I need c value. To calculate the m value and c value, we are using this formula. So what is my formula here? M equal to n into summation of xy minus summation of x multiplied by summation of y divided by n into summation of x square minus summation of x to the power whole square. So when we'll keep all these values which we calculated here, we'll get x value 0. M value 0.6, and in the same way we'll keep the value in this formula and we'll get c value 2.2. Fine. Now we got m and c value. M is 0.6 and c is 2.2. So this m and c value will keep in this equation and we'll find what is my y predicted in when your x is when your c is 2.2 and m is 0.6. So we for every value of x, we are trying to predict the value of y. Okay, and we are keeping the value in this y equal to mx plus c, and we are getting different y predicted value, and these predicted value we are keeping in the graph. So these blue dotted lines are representing the actual value and the brown dotted values are representing the predicted value. So this is the difference between actual x value of y and predicted value of y. So my actual value of y was this, and when I kept this value in this particular equation, I am getting the predicted value, which is mentioned here with blue dotted line. Brown dotted line. So, so the difference between, so here we have a difference between the actual value and the predicted value. So that difference is called a residual or error. So when we are saying there is no difference between the actual value and the predicted value, then it is called best line. And we should always try that this line should be a best fit line so that the error should be less. Okay. So the best fit line should have the least sum of squares of these errors, which is also called least square. Clear? How we are finding the best line here? Now this line is not the best line because we will be having the difference between the actual line and the predicted actual value and the predicted value. So what we are trying to do? We are trying to minimize the distance between the actual value and the predicted value every time. We are trying to reduce the residual or we are trying to reduce the error. So there are different way of minimizing the distance between the line and the data points. Like we can use sum of square error, we can use sum of absolute error or root mean square error we can use, and we can reduce the distance. Okay. So we'll always try to keep moving this data, keep moving the line through the data points so that the best fit line has the least square distance between the data points and the regression line. So we'll always try to make a best fit line here so that my error should be reduced. So finally, we'll get the best fit line here. So I hope it is clear that what exactly the linear regression works. And with the help of linear regression, we are trying to predict a value of dependent variable using independent variable. Okay. So for getting that value, we are using a simple equation which we are denoting through y equal to mx plus c. So we are keeping the different value of x and we are trying to predict the different value of y. And finally, we are finding the difference between predicted value and the actual value. As the difference is more, it means model is not learned properly. We have a more error. So if we want to reduce the error, the residual error should be reduced, and we'll try to find a best line where we have less error, or we can say the distance between the actual points and the predicted point must be decreased every time. So this is all about the linear regression. In the same way, we have multiple linear regression. So in the case of simple linear regression, we'll have a simple equation which is y equal to mx plus c. In the case of multiple linear regression, we have a same equation, but we'll be having a multiple dependent variable as well as we have multiple slope. So you can see here y equal to m1 x1 plus m2 x2 plus m3 x3 in that way. And finally, we'll be having coefficient c. So this is all about multiple linear regression. In the next class, we will discuss about logistic regression. Thank you.